So this is the gauging station. And of course, they say to start it, there's only two things, even though we're looking at, if we looked at the PLC program, there's really only two things to start this thing up. And what's the two things required to start it up? Down the limit switch and the start button. Single step it, right? You understand that? Then it says it's going to do what? It's going to extend the motor. This is going to affect 4S2, right? Then it's going to port detection, B1, height position. This would be B2. So that's when y'all got those messed up. You were seeing the ultrasonic sensor as B2. I'm sorry, as B2 when it's actually what? B3. And then it extends the lift cylinder, and then it comes up here and makes a watt.
I know folks know this stuff, but that's kind of in the wrong order.
What do you mean?
I mean, it's all that port detection and all that for the. So
Well, not true. This is all one. I got that. This is all one step.
Right.
Yeah. So yeah, I see what you're saying. So this is step one, and this is all that's going on in step one. Yeah. Yeah. So good point. Anybody else okay? Then it's going to extend cylinder 2A, which is the lift, I believe. Yeah, that raises it up out of the slot, of the alignment slot where it lines correctly. And then we got two ways we can go. We can either do what? Yeah, so if, this didn't give us, huh? Yeah, but these are what they didn't do here is they didn't give us the actual sensor depending on which way it goes. You see what I'm talking about? This says if input 2.3 is false, it'll go this way. If input 2.3 is true, it'll go that way. And then this right here has to be that this has to be B1. Yeah. So what they didn't do on their function chart is they didn't give us the sensor name. What they did is gave us the what? The actual input. So y'all wouldn't know that. So I need to go back in and make a correction on this. These was not put out by Amatrol, by the way. These were actually developed by Siemens. And then it retracts the cylinder right, and then it does what? Yeah, then it loops back around, which y'all can't see it. So it would help us troubleshoot better if they actually put that information right there. Y'all see what I'm saying? So undoubtedly, this is the function chart on the second module, or the third module, which is the what? What they call this? Indexing, I think. Indexing module. The one that's got the one with the carousel on it. That's the indexing. So y'all got most of this step motor to 45 degrees, right? You take it in front of what? There's the text B2. Then if B2 does not see it as in the wrong direction, then what does it do? It skips where? All the way down. If it does detect and all what's nice, the metal blocks, they can't be put in upside down because if you notice, and I can't draw on this, is the
Aren't the poles lower or something?
well, No, it depends on which side you look at it from. What happens is, if you looked at it, you would notice that the metal blocks, if you looked at them, and here's the two holes we're looking at, this distance here and this distance here is the same. If you looked at the acrylic box, they're narrower. And this distance here, if it's in there right, would be the same. This would be equal, but this distance, let me move it down a little bit. This distance down here is short. So it's only short on one side. So that means if I flip it around, then these two sides line up. You understand what I'm saying? Because what happens when it shoots that spool in there, that single hole right there, what it's looking for is it's not looking for this side, it's looking for this side, right? You understand? Yes or no? So it means even though I've got an acrylic one that's actually a little smaller, not by much, I'd have to draw this over. When it's oriented correctly, this side equals that side, it's this side right here is short. So what they're doing with that optical sensor, if this short side is down, it's going to do what? It's going to flip it over, right? If the short side is up, it's going to do what? And it does it by shooting the beam through this thing right there. But it does it right down here. I think it does it right at the top. So if the light beam goes through, it means it's oriented right. If the light beam gets blocked, it means the narrow side is down, right? You understand? And then it would decide to flip it. Because if it don't flip it, what's going to happen? Yeah, the spool's going to jam. Every time an acrylic would come out there, the spool would jam. So if I was going to do this and I got down to the other side and the spool jammed every time, then that would be, I would go back to the indexing station and figure out what's going on with that light, right? Or if it tried to flip everything. That's probably what happened. If the light went out, it would try to flip what? It'd try to flip everything, even the metal blocks. So if that sucker tried to flip the metal blocks, then I would know that either that beam is out of alignment, right, you understand, or it's out altogether. So this is the actual chart, function chart for the watt station, the index station, right? And then what's the last station we were looking at? The conveyor belt. So we should see some timers in this thing. So what we probably need to do is kind of play around with the speed of the belt. We usually run it wide open because we, like I said, it's something that we hadn't had time to get into. Yeah, so see what it says. So we come down here, it says what? Start cue, short time delay, 3 seconds, right? You understand that? Then it comes down through here. If it's metal, then what's it going to do? Short time delay, then it's going to extend that cylinder, which is going to do what? Push it over, right? If it's acrylic, it's got a counter too, by the way, guys. I don't think that's in there, where it's going to keep count of the number of acrylics, and it's also going to keep count of the number of aluminums. And undoubtedly, it passes this over to the robot, so it'll know which side to go to, right? You understand? Does that make sense? Then this would be the acrylic, so it would come down this line right here for the acrylics, right? You understand? And then over here, it would come down this line right here for the what? For the metal.
And what would it count? Would it count, number of times
Well, no, what it does is it knows what they are depending on this guy right here. And this is another instance where they don't tell us what it is, right?
Because what I'm hearing, like, you said, counter critical, what counter critical, I gotta know what, who's the counter critical, who's the counter no. Right?
Right. Well, what happens is if this would be depending on this guy right here, right? You understand? It's B2. If it equals to a 0, then what's it going to do is it's going to come down this path right here. If B2 is equal to a 1, it's going to come down this path right here. So what's B2? So what they didn't do there, B2 would probably be the what? Yeah, I'm sorry. I've got two tables up here. I have people that do that too, but they'll sit all the way in the back and says, I can't see that. And what do they say? Baptist sitting. So construct is the one I needed to open up. No, I didn't want to do that in Rich. So the construct shows us I think the picture that shows us where all the sensors are. Yeah. So there's B2 right there. So B2 is the ultrasonic sensor. I'm sorry, the B2 is the metal detector, the inductive sensor. So depending on B2, it decides B2, it counts, if B2 is false, it's going to count acrylic, right? You understand? If B2 is true, it's going to count what? Metal. So if B2 is true, so if B2 is equal to a 0, which says it's false, then it knows it's acrylic and it'll come down this line right here. Right? That makes sense? If B2 is a 1, it means it's metal, then it'll come down this time right here. No, it's not. Well,
I mean,
not, it's,
I'm thinking.
yeah. What is this guy right here would be, this guy right here is a ultrasonic, it's a retroreflective. So that means if a part is present, so they got this basically, we'd have to look at this, guys. So normally a retroreflective, no, this is the metal detector. So it's usually a normally open contact. And if what it senses is true, it simulates a normally open contact, then what if it senses it's true, the output goes to a 1, and what it senses a false, the output goes to a 0. Makes sense? So a lot of your sensors use normally open contacts, or simulate, they use solid state devices, but they simulate normally open contacts. All of them. So that's why a diffuse sensor, it goes false when something breaks the beam, or a through the beam goes false when something breaks the beam. So if I was looking at that sensor that senses whether it's oriented right, I'd say if it's false, it's oriented right. If it's true, if it's true, it's oriented right. If it's false, it's oriented wrong. You understand what I'm saying? So that's something you got to figure out. And I don't know if I can zoom in on this. I know I can zoom in on this, guys. I could just. Oh, this is yeah, right here. So all these solid state sensors that are not 4-wire sensors, if it uses the black, that's a normally open contact. That simulates a normally open contact, but it's going to do it with a transistor. So through the beam, when it don't see something, it would be true, right? You understand? When something breaks the beam, it would do what? It would go false. It makes sense because it senses light, right? The metal detector, it senses metal. So when it sees metal, it'll go true. When it don't see metal, it'll go what? False. If that makes sense. So that's what they're saying right here. So it says, okay, if B2 is true, it must mean what? It must mean it's metal. So it'll come down this line right here. If B2 is false, it must be what? Acrylic, and it would come down this line right here. Right? Does that make sense?
I was just thinking about writing the program and writing for my count. And what kind of.
Well, every time, well, you would count off this guy right here. Notice there's no lines between these steps right here. So basically it means these are controlled by the same sensor, right? Understand? So they call this 3. But what's required to go from 3 to 4A? Nothing. What's required to go from 4A to 5A? Nothing. What's required to go from 5A back over here? Yeah, B3 has to be true. Now something it looks like they're missing on here is it looks like they got them backwards. So this right here is B1. So it looks like they've got this, looks like this should be over here, shouldn't it? Understand what I'm saying?
What about the retro reflector?
That is B1.
Oh, retro reflector.
No. So here's, so B2 is the inductive sensor. B1 is the retroreflective sensor. So it looks like they've got this kind of backwards. You understand what I'm saying? So B2 should be B2 should be right here. So it should be start and B2, and then that would fall us into this line right here. That makes sense. So this says B2 is triggered by the motor starting, but that's not true. So whoever did this one made a few mistakes. So they're saying this guy triggers B1, but that's not true, is it? Yeah. So B1 should be up here. So they did something wrong right here. They didn't show what's required to get into this loop right here. So B1 would have to be true. And then if we're single stepping, the start would have to be true. So what they should have up here, they should have a B1 and a start. And the motor doesn't trigger anything when it starts. So this right here should be what? Should be blank. And then if B1 comes true, then it also starts the cue. So there should be no step between this. Starts the timer. So as B1 comes true, if you ever notice, you put the block down there and the motor don't start up instantly, right? Put the block down there, waits a couple seconds, and then it starts up. So it looks like these blocks right here shouldn't have a line. So that's the true flowcharts, guys. And like I said, even though this was done by other people, you can see even those guys have little problems. Yeah, this is definitely wrong though. So I'll go back and correct that. So these blocks right here could be okay, but there should be no transition between these blocks. And then we should up here have the start and what B1. Then this doesn't affect B2. this B2 would come into play down here. So this is right here. So if B2 is false, it goes this way because it's acrylic. If B2 is true, it goes this way. And these look like they're okay. So when it extends, it does what? How does it know it's extended? It's going to be B2 in that case it's extended. How does it know it's retracted? And B1 would be that. So those look okay. It's just up there at the start section that looks like they did that wrong. So, y'all notice the test was supposed to be today. Y'all know that? Yeah, we changed it because, like I said, we held off so long on trying to get everybody here that I delayed a bunch of my lectures I shouldn't have delayed. So, we got one thing, we got another thing we need to go over before the test. Then, we'll make sure we try to get back into the lab. Depends on how long this takes. But this information I'm going over right now, this is going to be on the test, which is going to be Tuesday, right? It will be in what they call professional development.